My name is Eldar. I'm with the GEM Office Service Desk here in Chipwood, and John Paul will be helping me hopefully during this discussion, and do a lot of slides and go through most of them sort of quickly. You guys, most of you are pretty familiar with these things, but we'll try to highlight things that we've done since last GC, and hopefully get some things that, some questions and some discussion on future challenges and ideas and things that we're, as GENI grows and for the upcoming solicitation. Okay. So, if you call us, you will either get somebody in Indianapolis or Bloomington. So, just imagine that these are all the tools that GENI has today, right? All the pretty management, measurement data, learning, and all of that, right? Right, yes? Some of that is. So, some of that information actually is GENI related, and we do get active alarms on, especially on the internet too, and MOXIE parts of GENI we are responsible for, low visor phone instances that are that we actively monitor at the university. So this is what GMOC is. This is some things we do. Monitor the GENI overflow network. Monitor in a different sense that normally we would. Some of it is proactive, some of it is, most of it is, of course, through the GMOC DB and the measurement APIs and the snap graphs that a lot of you have seen. If you haven't, go to our website, take a look. So, of course, one of the major things that we do is the emergency stop. What we're responsible for is gathering contacts for each of the GENI aggregates that connected to the mesoscale, and making sure we have a primary contact and an escalation contact. Primary, a lot of times, list at a site includes multiple people, but for the escalation contact, we do need a person, an actual person, someone that is going to be responsible for the aggregate and that we can get a hold of if need be. You'll see a little bit later more workflow, and of course you can go to the website to get more familiar with the whole process. Sounds complicated from the diagram that I'll show later, but really from some of the things that we saw past couple of weeks when we did emergency top tests or dry runs with GPO and the RACS teams, specifically for the RACS, it actually was sort of a breeze. So we'll see. I'll talk a little bit more about that. So GENI experimental support. This is kind of in the early stages right now. You know, obviously we're 24/7 operations center, so you can call anytime. Any experimenter can call anytime, and we will at this point be able to at least point you in the right direction. We can, you know, if somebody's having a problem with infrastructure, either on the backbone or the regionals, or we can tell you at least if there's anything going on in GENI that we know about, and then if we can't help you, we'll point you towards somebody that can. So manage network systems, alarms, outages, maintenance, mesoscale provisioning. Maintenance freezes, so for GEC16, a lot of times we'll send out requests to stop any kind of maintenances that happen on the infrastructure. Demo reservations, so if you're doing a demo and you would like certain resources to be reserved, let us know. We'll send out and try to do our best, because obviously of just the nature of this network, a lot of times we can't dictate, but we'll do our best to work with our partners to get those reservations in place. And something a little bit, we've been doing this for a little while, but disruptive experiment reservations, where if an experimenter is doing an experiment, and we send out some lists of things that are considered potentially dangerous and potentially can cause disruptions on the and cause disruptions for either aggregate operators or for for other experimenters on the mesoscale, to get those on the calendar and to reserve that time during which we know there's possibility that you've got some sort of an odd topology, a loop topology, or high bandwidth traffic testing that you're doing. Let us know and we'll get that reserved. And something recent that we've been doing is doing a little bit of post-mortem on these, and we'll be working more towards, as we go, we get more of these to really learn from how these kinds of experiments and our measurement tools really line up to do a post-mortem, to see if if a flow visor fell over at Dempsey or GPO or wherever the resources were observed during this experiment, and to see what can be done to better prepare these experiments in the future. Notifications, escalations, reporting normal things were a little bit different from the standard operations, but I think we are sort of getting our heads around it. I think providing at least some sort of some reasonable notification escalation. Obviously, we'll be doing more improvement as the time goes by. But so engineering configuration for specifically for Internet 2 as you're getting ready to make your mesoscale connections. Work with GPO and probably Tim, and you'll work with us to make sure you're all set up, and also coordinating with NLR if you're making connections with them. Bringing up new aggregate site, regional or GENI rag, and one of the posters that we have to share from the demo covers that. So, and I'll have another slide on that. The measurement, of course, API for the GENI aggregates for sending measurement data from your aggregates to GMOC, making sure you're all set up, and developing any new tools for network monitoring and measurement. So some new things that happened since last GEC. Some, unfortunately, some of our software guys weren't able to be here, but Chaos will go into some more details on that. And but something from services perspective that's been helpful to us is getting some of the UI redesign and improvements. Very useful during the recent emergency stop test that we did with the RAGs, at least. Functionality-wise, time-wise, getting things, find out things, contacts for the emergency stop and things that are effective quicker. The back-end redesign, including data download from the GMOC DB. So some of the chaos, we'll talk more about that. Sort of working, sort of not. More to come, but at least it is useful. And other things that cleaning up the GMOC DB, whether improving usability all around. A few storyboards. This was something I was showing at the demo session last night. So this is just showing that. So these are the snap graphs, the measurement graphs that we're talking about, where you can go see any of the racks or regionals or backbone for provider aggregates that are sending data to GMOC and various measurements. Still, of course, a lot of it work in progress, but major things are there and useful for us. So this graph in particular is showing the Internet 2 flow visor that has for a long time, so I guess since the beginning of GENI, really, this is showing DPID numbers. So data paths they're going through that the flow visor sees. And so for the longest time we've seen 20, and all of a sudden it jumped to 45. So then that happened after GPO worked with Internet 2 and NLR, and I believe the regionals as well, to inject the open flow VLANs for the racks. And so that's the reason you're seeing this. So this is the turn-up process, a little more outlined and really set in place. Well-defined. So this is on our website as well. You can, as you're ready to turn up your aggregate, you contact us as soon as you get your rack, or as soon as it's getting ready to make connection to the mesoscale. If you don't, GPO will gently point you towards us and let you know to get this process started. And basically, you will get a notification when a ticket is open, and then once all of these pieces have been completed, you will see a closing notification. Our systems group will work with you as well to get the monitoring and the measurement API data set up and accounts set up and all that. So some tools, some kind of screenshots of different things of ticketing system, alerts, see, and so this was a large one that Tim asked me to blow up and make big, so I went ahead with this. These are useful. For me, they're useful, and I know for Tim this has been useful. But so I think one of the best tools that we have that's so easily overlooked. So these calendars are there. This will give you just an overview of if you had an outage, if you had a problem with your experiment, suspecting a problem on mesoscale or previously, future, current. This will show it all the different events that have happened that possibly could have affected you.
Some of those were scheduled, though. There weren't all.
What's that?
Some of those were scheduled outages. They weren't.
Sure.
all
So
problems.
and that's what I mean. So this includes previous maintenances, future maintenances, any current ongoing outages. All of this will be on these calendars. So you can filter by whether it's an outage or maintenance. Emergency stop process. Again, hard to see here. I'm not going to go into it, but our website, and there's a link there. Get that out once we get those slides uploaded. I'm sorry, my credentials for the wiki here. I didn't get those today, so I'll get those slides up there. But so a few items since last GEC. So I mentioned the emergency stop tests that we did with the racks, and GPO acting as experimenter. That for the most part have gone pretty smoothly. We missed a few steps that I think we know pretty well, and just for the sake of not taking up a lot of other people's time, we missed a lot of those steps, or skipped those steps, but for the most part things went smoothly. We've kind of identified some UI things that we could use improvement on as far as on our side, but also just overall, more realistic, I guess, ways of an emergency stop. So, in this case, it's these are scenarios. Chaos contacted us with a really nice URM and told us which rack it's on, but real life that's not necessarily going to happen. So, they was like, we'll send us an IP or a MAC address or some other resource that. Currently, there's searching things that we will need to fix, and some topology information that's there, but it's not meaningful, and to help us better find the source of a problem that somebody's reporting. So we'll continue working through those, and so. Bi-weekly operations report on the network core calls. So those of you that have been joining, you've sat through those, and so we've included some rack outages, maintenances on those. Again, a little bit different from the standard operating reports, but still hopefully useful. Hopefully gives us an opportunity to review and do some postmortem things, talk through any issues that we have. So different GENI regionals that are monitoring, that are monitored by GMOP. The ones by the stars are new ones. So Scenic and Isomet since last GC have started sending us data. Next to GENI racks, so Kentucky Northwestern have come up, and FIU and UH are almost there. Well, most of the pieces are there. We're just final stages of getting that set up. And so this is the slide I kind of wanted to get to. So some future support needs or challenges or ideas that we have, at least in our mind, and hopefully you guys can help me with some other ones that you think are important. I know one item that keeps floating around, keeps coming back from some long GC, previous GC discussion or presentation that John Paul did is on targeted notifications. And so we realize that's an important part, and we're going to try to get some tools for that and ideas of how to better target notifications. And, hopefully having some discussion with Proto-GENI folks on getting better, more meaningful notifications for them, and as well as, as really experimenter support ramps up, having target notifications for that as well. Of course, all of the aggregate operators are currently getting notifications, but even there, I think we could probably do a better job of more targeted notifications for that. So we'll hopefully keep you guys updated on that. So I mentioned topology, being able to see really what a slice looks like. 5 minutes, okay. And especially for the emergency stop and some other needs, I'm sure you all can think of different things that hopefully once we get the download for the GMONDB and also some more public access to the GMONDB information. And once you start using this, hopefully we can get other topology and different things in there. Circuits and nodes in the GMONDB that obviously we talked to Tom about that in previous GCs. Hopefully those are some of the next things we'll focus on. Proactive monitoring, alerting. So currently there's very little of that. Rely on pretty much racks or other entities to support, report any outages that they have to us, and for us to track those. And I mentioned the disruptive experiment postmortems. So if just for those of you that are aggregate owners, if you notice that during a particular event or during a scheduled demo or a disruptive experiment reservation, if there are or maintenance or something of that sort, that your flow visor has started acting weird and has completely failed over. Contact us, let us know. Usually make sure you include the ticket number that's associated with the event. Let us know, and we'll do some postmortem on that and follow up. And there's some folks that I think will be helping us with some of that. I know Nick is Nick Bastian has helped us with a couple of those. So we're hoping to get some other people involved with some of these postmortems. And I think another part of it is using the current measurement tools that we have to work associate with these events that happen. So it is important. So if you have those things that happen during these events, let us know. And postmortems on other multi-flow specific operational issues. So tracking outages at regionals and other dynamic VLAN service providers like ION or AL2S is a challenge. Obviously, and I don't know how much of that we need, but some of that I think we will, especially as we move forward into more of the proactive monitoring and alerting. So if there are alerts, we certainly need to know more of the topology and how each of the aggregates connected to the mesoscale for us to be able to to better track all of these events that happen. And maintenance freezes. So how, as GENI grows, as more racks and more regionals join, how scalable is having a maintenance freeze for GEC? We do our best, but even then, especially with some of the dynamic service providers, they're not used to, they're really relying on the customer. You build this dynamic VLAN, it's your responsibility, right? But at the same time, for a demo for GEC, how can we better provide a freeze for that time frame or for that demo for that event? So, any other, John, Paul, or Marianne, did I miss anything? Anything else?
I think, most of all, it's important for us to hear from you about what's important for you to see or for us to be doing. So certainly any feedback that you have, we'd appreciate that today.
Anybody else have any other items that you would like to see? Anything that you've seen that you would like to improve on?
I'll just echo what you said that I requested before. That big calendar that you pulled up. I feel
Yeah.
like
So see, I tried to make that the subscribe ops calendar a little bit bigger. I didn't make it big enough, but I tried.
yes, that's perfect. But if you're an operator in GE and you want to know, gee, I wonder if there's some Internet 2 maintenance going on that's causing this, or something like that, then you can bypass asking us and go straight there and subscribe. You can do it right now. You can subscribe right now.
There you go.
One of the things that may not be clear from that listing is that you can in fact put it on your Google Calendar. So if you like having lots of things on
iCal,
your Google
RSS.
Calendar, then yeah.
We could make texting, dynamic texting, right? Over.
I have a suggestion for the long-winded URL after.
Okay, tiny URL.
No,
Or
no.
what's the suggestion?
We have this little thing. It's fine.
You sure? Okay. Guess I'm out of time. Thank you.
Eldar, continuing. Is this yours?
No, that
okay.
shit's there.
Oh, it's probably mine. That's fine. Oh no, good, mine. That's somebody else's.
Community collection. That's why I
Yeah.
label all those.
I know, mine is a big piece of masking tape on it because I do that all the
Yeah.
That also serves to make yours really ugly so nobody wants to steal it.
time. Right. Whoa, that's,
It's okay. It's okay.
well, I'm not showing anything that's all that exciting, so I apologize for the letters being narrow. I should probably use the mic, right?
Yep.
Yep. Okay. Hello?
Oh.
Great. Okay, so I'm Golubitsky from the GPO. I'm just giving the periodic status update on the work that we've been doing where we is primarily Am I getting that weird feedback?
Yeah.
Well, I don't know what to tell you. I will move the mic down and hope it goes away. So primarily engineers at GMOC have been writing this code and maintaining the system for shared operational monitoring. Also, obviously, developers in the OpenFlow community, developers at the ExoGENI and InCommon rack teams have been doing a lot of work to make sure that we have data that can be submitted to this, that people can look at. And basically, this is just the status report on what's new within the past year, and especially since the last GEC. So, Obviously, what is, operational monitoring data? Obviously, this is pretty well known why we want operational monitoring data. So basically, GENI has a lot of fairly specialized things in it. Experiments, slices, slivers, that your standard monitoring package isn't necessarily going to know what those things are and isn't going to have boxes to put them in. So we've been trying to make some boxes for things that look like the kinds of things in GENI, so that when we share information about how things are doing, they're in a format that makes sense. And so we want to get visibility into the state of all of these things that are in GENI, experiments and slices, which are located across all of the infrastructure in GENI, and both the networks that are controlled by GENI and the non-GENI networks which are used by GENI experiments. We expect that both experimenters and operators might want to look at this data in order to debug problems with experiments or to resolve outages, and in the case of operators, presumably also to detect outages, and maybe experimenters might want to do a little bit of that too in the context of their own experiments. So the primary home for all of this stuff, GMOCDB, is a shared database that contains relational and measurement information about the state of GENI aggregates. So what is that? So relational data is, I should know my slide deck. I will get more into that in a bit, but basically the model is that aggregates and resources in GENI can report data in, so basically anyone can report data in, so either someone who's running an aggregate that has some software written for it, just a little utility so that it can collect information about GENI objects and submit them, or if you are running an experiment which is a test about the state of GENI, so if you are, doing some pings across some infrastructure, or a test that we've had going for a long time is a test that goes out using the AM API and talks to aggregates and says, are you responding to get version right now? Are you responding to list resources right now? And we can use this API to report that data in, and so that anyone who wants to know, gee, get version isn't working for me. Is it just me, or is that aggregate down? And if that aggregate is down, how long has it been down? Can go to a centralized place and get that data, and they don't have to go back in time and realize a week ago that they wanted to start running this check. So that can be useful. And then views into looking at the data. There's a web UI that you can go to and look at the data. And also, and this is one of the big new things that I'll be talking about here, you can download data that has been reported recently, both to a limited extent measurement data and also now relational data using programmatically. So you can write scripts to do this, you can do it interactively on a command line, etc. So, reporting tools, gmoc.py is a utility that's been in the works for about 6 to 8 months or so, and it makes it easier to report relations between GENI objects and measurements about GENI objects. So relations, basically these are objects that exist in GENI, and again, these can be sort of specialized objects that don't necessarily exist in other kinds of networks, things like slices and slivers and aggregates, and of course, and also things like resources and interfaces, and things like that other kinds of networks also have. And then also you can use this utility to report measurements, which are operational metrics about those objects. So you have an aggregate object and you say, okay, that aggregate also has, also has a CPU idle, or also has, some other measurement that may say how healthy it is. And the kinds of measurements you can report can be, again, things that are kind of specialized to GENI, or things that are pretty generic to any kind of infrastructure. So in terms of who is reporting data right now, we're hearing from 2 ExoGENI racks, 4 InstaGENI racks, and as Eldar was saying, and many of these things didn't have asterisks on Eldar's presentation because they were reporting data, as of a while ago, but they're now reporting more data. We've, a big improvement that we've been made recently is getting data about what, I am really sorry about that, I'm not sure what to do about it, about what GENI slivers are running on each rack at a given time. We've been working pretty hard to, to get that data reported in, and now lots of people are showing that. And then 26 foam servers, which are at mesoscale campuses in racks and at regionals and backbones. So obviously you can't see that, but that's a list of some of those reporting aggregates sorted by last updated time, and basically there are a lot of them, and if you could see details about them, you could see that they were of those different types. So that's pretty neat. And thank you to everyone who has worked on getting your data in. Data download. So you can use that same Python client now to pull down relational objects and recent operational data. Campus operators who are submitting data can use this right now. We are working on the process of getting experimenter access to it, which basically just means tidying up the access control within the model. So basically, I keep saying there's a Python client you can use, and the point is that the purpose of the client is to make it very easy to do this, but what's under the covers is for upload, there are some XML-based APIs that are used for upload right now, and for download, there's a JSON-based API. So basically, the Python client is a simple wrapper around those things, but it makes it pretty easy to use. And here's an example, and if I have time at the end, I'll give you an interactive example, but basically, you import this, you initialize your client with some arguments which I've elided, but basically it's a username, a password, and a URL. You can, if you're reporting monitoring data, you can get those values from your existing monitoring config. You define an object that you want to see, you say, which is a slice, you say, I want to load that slice, and then you can look at properties of it. So basically that load, so behind the scenes, between those two lines, about 700 seconds right now pass, so this isn't very fast right now, but basically what it's doing is going out and getting that slice, and also all of the slivers that are connected to that slice, the aggregates that those slivers run on, the slice authority that's defined on, and basically just, and just sort of pulling down the data that you might want. And obviously, a future improvement might be to make that download a little bit lazier so that you're not pulling down all of that data to do a simple query. But on the other hand, for our use case, which I'm going to get into in a little bit, which is to pull down all the data and then do monitoring checks on it on our own, it works okay, because we're actually using all of the data, so pulling it down in one piece is fine. So we've pulled down our slice object, and you see that you want to count your slivers, and there are 14 of them. That's great. And then I'm picking on Tim here. This is a monitoring slice that he uses that has slivers across a bunch of GENI infrastructure. So I just, and then that last one is a little bit of Python code that says what's the minimum expiration time for any of those slivers in that slice, which is something that you might want to know. If you were an experimenter, you might want that to send you an email if that time gets too close to right now and remind you to renew your slivers. And a lot of aggregates might be emailing you, but in case they didn't, or in case you missed the email, that would be another way to find out operationally what did those aggregates think is happening with your sliver. The use case that we use the most often in GPO is operational alerting. We've been doing alerting with data downloaded from GMOC for a long time by pulling down recent measurements. That's a little bit hard to do. We've had to do some glue code to make it work, just because it's basically the API for the measurements is not yet very user-friendly, and that's something that we're actively working on. The API for downloading relational data is very user-friendly, and I would be happy to recommend that other operators who are interested in monitoring GENI data do this right now. It's very easy. So basically, our Nagios, so basically we run a check that goes out every once in a while and pulls down the latest object with all of the measurement data and then runs some checks on it. So right now we're looking at aggregate versions and saying, gee, if your aggregate is now running a version which is not in a set of versions that we expect, then we want to hear about that, which can be useful if we're, if people are upgrading, or it can be useful if if we may want to know if people have upgraded past a version that we've tested, just so that we're aware of that. And then another thing that we've done that has helped detect a bunch of outages or a bunch of issues in the mesoscale is we look at, so foam is the aggregate that is the GENI aggregate that sits in front of FlowVisor to serve open flow resources, and so we want to be able to look at FlowVisor under the covers, thinks that it has all of these slices, and foam thinks that it has GENI slivers, and ideally those things should match, but because of some sort of problem they might get out of sync, and so it's easy to, that could be hard to detect by hand. It's really easy to detect with this kind of monitoring, that we can sort of say, if there's anything in FlowVisor that doesn't look like something we would expect to see from foam, let us know about that and we can look into it. So that's been great, and some of you guys who operate foams have heard from us about alerts that we've gotten from that, so that's been very useful. And then sorry about the URL, that's basically our Nagios subgroup for all of the stuff that we look at that is on GENI infrastructure and primarily using these checks. So as we add more things, they will show up there, and definitely feel free to ask us about anything you see there. If it's something that you think that you'd like to be running, if it involves relational data, that's pretty easy, you can do it. Another thing that I wanted to draw some attention to, because it's not very visible but has involved a lot of work behind the scenes, was to clean up a bunch of stuff that had been in the existing GMOCDB and clean up the insertion of new records into the database to make things much faster and more scalable, and to reduce load on the server, so that so that we can actually do this and it works out. And then also using these tools to take a good look at the details of the data that's in the database. Are aggregates actually reporting the things we think they are? Do we have the information about campuses that we think we do? And working on cleaning up some of that. That's still ongoing, but we've had a lot of help from Eldar and other people at the service desk to work on that cleanup. So that's been great. What do we want to do next? I mentioned that right now downloading measurements is a little bit hairy. We would like that to be using the same Python client and the same mclean API that we can use to download the relational data, so we want to get there. Right now, ACLs for the data download are all or nothing, which is an okay match for operators. It's not a great match for experimenters. So we want to fix that so that we can also encourage experimenters to be doing this kind of command line download and getting information about their experiments. This was a big focus in Eldar's presentation. Everyone needs to know more about what's happening in network devices on GENI, more about circuit topology. So we want to get that information We want to get that information into the database so people can see it. And we also want to have better, improve the user interface so that all of the changes that are in the data are definitely showing up in the user interface, and people can see the same stuff just by clicking around if they want to look at things in real time rather than downloading. And then also, we obviously want to keep improving the data that's being reported and keep working with aggregates and people who are doing operational experiments to get that data into GMOCDB so that people who want to use it can. If you want to try out data download, please get in touch with us. We're very interested in people doing that. If you have operational metrics that you think should be reported in GENI and would like to, add that to the standard set that the Python client knows how to submit, let us know that. That's very easy to do, and we'd like to have more of them. And if you are running health tests in the GENI or want to be or have ideas, that would be great. Those kinds of things definitely belong here. And any kind of feedback. There's a mailing list, monitoring@geni.net, for the project of operational monitoring in GENI. The GMOC engineers who have done most of the work on this, Dan Doyle and Mitch McCracken, unfortunately couldn't be here. I think Eldar said I would tell you more about what happened to their plane. I don't actually. So unfortunately they got stuck in Indiana and weren't able to make it to this GEC. But they really did a lot of work since the last GEC to make this all work out. So that's been great. And Sarah Edwards and I have been working at the GPO on testing this and helping out with writing in client software. They're not on my slide, but I'll flag Jonathan and Victor, who've done a bunch of work on making reporting work for GENI, because we've also appreciated that a lot too. How many minutes do I have?
One.
All right. Well,
no, sorry, 3.
3. Oh, well, 3 is definitely enough to show you guys the command line.
Oh, we can't see them.
Yeah.
Oh.
Here. Look, it's a big terminal. So I pre-queued that. You guys probably can't see what's happening at the bottom at all, huh?
No, I'm in the front.
Okay.
Can anybody else see it?
Let me make it bigger.
Just go for it and hit return a bunch of times when you're done.
Yeah, okay. Well, all right. Anyway, so I pre-queued this by getting the URL of our slice authority and then loading it as a slice authority. Again, that took about 10 minutes, but now we have it. It has an ID, so it's called that. It has a bunch of slices, which are kind of messy. We can look at this and say that right now it's reporting 70 slices. We can, if we want to find out, say, I don't actually know what I'm going to get here. Let's find out. So the randomly selected first slice, oh good, is one of mine. Unfortunately, it's one of mine that doesn't have any slivers, so it's not going to be that interesting. But yeah, so that's all right. Okay, so here's one that has a sliver, so we can look at that sliver and say that sliver is at an aggregate, and yeah, so whatever slice this is, it has a sliver at the aggregate foam1.gpo lab, which is our test foam, so it's probably a testing sliver of some sort, which is great. And we can look at that sliver's resources. Okay, well, this is a live demo. I don't know. Okay, so then this is, so this is a sliver in plastic slices. I don't know what's up with that. That's interesting. I would have expected some of those to actually give me some resources. But anyway, so this is at an aggregate, which is foam.nlr.net. So let's call that NLR, and then NLR should have some resources. Right, yes, very good. Yeah, so then this is a bunch of resources. This is going to be all of the data paths at NLR, and if we print this, then we can see. And so you can see, here are all of the data paths that we have in NLR. There are a bunch of them, and they can be shared by OpenFlow, and we can find out information about all of those data paths, and eventually we should be able to get measurements about them too. But certainly if they all went away, then we might want to know about that, and this could kill us, so that would be cool. Anyway, I think I am out of time, but the point is that you can, you can pull that down and look around and get operational information and make it set off alerts in your Nagios, and that's all pretty easy now. Thank you very much, everyone who has done work to continue making progress on this. This is great. So.
Thank you. Tom, you're up.
Sorry, I should have warned you. By the way, Tom, the mic was live.
So how many people here went to the earlier session about stitching? There was a session yesterday? Oh, really? Okay, good. So this won't be repeated for anyone except GPO folks. And this is specially tailored for the operations and network engineers, so.
Is it?
Yeah.
As far as we know.
Gotta say it with conviction, Tom.
It is. Okay, hello, I'm Tom Lehman, from Maryland, Crossroads. So I'm going to talk about stitching, and I do have some slides in here that I'll probably skip over pretty quickly because they were presented at the developers meeting yesterday that are a little more, maybe not of much interest, so I'll spend some time on some other slides. So if you see me cycle through it, just because I'm skipping through ones that may not be of much interest, but I guess stop me along the way if you have questions. So just to reset, is the mic volume okay? Can you guys hear me? Yeah, okay. Just to kind of talk about stitching at a high level initially, and then we'll talk about the details. Is that when we talk about stitching, it's really a GENI resource issue first. It's the networking issues, the fact that we have networks in between the GENI resources is really secondary. It's what adds the complexity. But we're really talking about in GENI, we're creating slices, which are some resources inside of a GENI resource, such as a GENI rack. And we need to be able to map those resources inside the GENI rack to the stitching VLAN. And the stitching VLAN is simply the VLAN that needs to be expressed out to the edge of the GENI resource, like the GENI rack. Basically, what gets the VLAN that gets expressed to whatever the GENI rack is connected to externally. So even if we had two GENI racks, say a GENI rack at ProtoGenie and one at BBN, and they had a direct wire between them, we'd still have to do stitching because we're going to pull up individual slices, individual sets of resources inside the GENI resource. We need to associate a VLAN that's specifically mapped to those slices, and that's in a simple case where we only have two GENI resources. It can be pretty simple, but when we start adding multiple GENI resources and we start adding all these intermediate networks, this is where it gets. That's where we need actually a stitching infrastructure. One thing to note is that this is a little bit different than mesoscale. I mean, there's still when you talk about mesoscale, you have a shared VLAN. So we're really thinking broader than that. We're thinking about a bunch of GENI resources out there in the world, and we're trying to get slices and stitching VLANs all mapped up together across multiple GENI resources. So mesoscale is kind of like a special case of that in my view, where we end up stitching to a shared VLAN. So just to note that there is for people who have been kind of really focused on mesoscale, this is a little bit broader than just mesoscale. So as I mentioned, even if we didn't have any networks in the mix, if we just had some complex topology of a bunch of GENI resources with direct cables between them, which we could never afford to build because they're actually distributed, we still have a stitching problem. We still have a stitching solution that's required. We still have to build a stitching infrastructure. Because this is really the real world that we're working in. At least when we think about developing a stitching architecture, this is kind of the big picture of what we're trying to solve. So we know we have a bunch of wide area networks out there like Internet 2 Zion and the AL2S and NLR. We have exchange points which lead us to other networks. And we have regional networks, we have campus networks. And in the end, we're going to have these GENI resources popping up all over the place. And an uncontrollable manner that we really can't control for the most part. There is some planning to where they show up. But, and then there's mesoscale off to the side. So basically, so this is the environment that we want to be able to do stitching in. This is the environment where we want to be able to have random GENI slices, resources inside of GENI racks be pulled up and across multiple aggregates or multiple GENI resources and get stitched together with stitching VLAN. We're talking about stitching, we're really just focused on layer 2 VLAN stitching between slices. So gluing together slices inside GENI resources with layer 2 VLANs. Stitching could be broader. The architecture is intended to allow other mechanisms of stitching to happen later, like maybe someone might want to stitch together slices with, IV tunnels, or just some UDP flows, or maybe something lower level, possibly in the future. But right now we're just focused on stitching the Ethernet layer. So here's a real-world example that we've been testing with recently, where we have an instant GENI rack that's available to us at BBN. It comes through regional network NOCs where there's some static VLANs. It hits Internet to ION where we can do dynamic VLANs. ProtoGENI Utah has 6 connections into ION. There's a ProtoGENI rack behind there. We have similar types of connections going through Chiron and University of Kentucky to ProtoGENI instance down there. We have Lonnie and LSU, which has a ProtoGENI instance that we've been testing with, and we have resources at MAC. So this is kind of the real-world example that we've been testing and developing the stitching environment on. And if you look at, these are some examples of some resources that we might have stitched together, and we have stitched together, and with what we're showing you in the demo and what we've been testing with over the last several weeks. And if you notice, Internet 2's ION service, they run a GENI aggregate manager on top of their ION service, and I'll talk a little more detail about that later. But what it does for us is that it allows us to use a standard set of GENI tools to make things happen in ION. So if you're running Omni Client, you're trying to get a multiple aggregate slice, you can use your Omni tool to talk to ION just like you talk to any other GENI resource like a GENI rack. So, what we're really trying to do is operate in that environment where all these GENI resources are, just kind of get dispersed across this network infrastructure, this ecosystem, in a very organic and ad hoc manner, which we just want to be able to accommodate kind of whatever happens in the future. And we're really talking about campus networks, regional networks, wide area networks, exchange points. And one thing that we all recognize that if you look at the GENI API, it's really the only GENI API out there that I'm aware of that's widely used now that has host, networking, and federation. So we want the stitching architecture to be able to absorb lots of different types of provisioning technologies that might sit underneath it. So if you talk about how these stitching VLANs or these VLANs can get provisioned, people have lots of options. They can just go into their network or to whatever's attached to their GENI resource and statically pre-configure a range of VLANs. They might pre-configure 20 VLANs which are attached to the GENI resource heading out to the next piece of infrastructure. They can also be running some type of dynamic VLAN provisioning system, like DCN, which is Oscars-based, DINES, which is Oscars-based. We expect that we're going to start seeing people deploy OpenFlow or NSI-based solutions in the future. Campus, regional, wide area networks, exchange points, they have their choice of which one of these methods they want to use, and they might come up with some methods we haven't thought of yet. We want to make sure that the stitching architecture, expressed through the GENI AM API, can absorb and basically cover whatever these networking technologies that might be used now and in the future. So that's been a big focus of the overall architecture. So if you're a campus, a regional, or wide area network, or exchange point, you do have multiple options to basically integrate your GENI resource into stitching. So if you have a GENI resource, like a GENI rack that gets placed on your campus or on your regional network or your exchange point, the options that we're currently thinking and working with and testing with are you can pre-configure that range of static VLANs, which basically just leave whatever port that is on your local GENI resource or GENI rack, and if it needs to make its way through a campus network or the regional network, you just pre-configure a range of VLANs and get them out to the next egress point. If you run a dynamic system like DCN or Oscars or DINES, you can run that just as it's natively done. You don't have to have a GENI aggregate manager covering it. That would be your second option. The other option is you can have a dynamic network system. You might run a GENI aggregate manager which is covering it, which kind of makes it more integrated thoroughly into the GENI system. And I think other people will come up with other methods. So if you're one of these types of networks and you end up with a GENI resource in your space, you need to think about, okay, which one of these methods do I want to use? And then there's several considerations about why you might want to do one versus the other, which probably could be a longer conversation for people we're actually thinking about doing it. But in all cases, in order to get that resource into the stitching ecosystem, the stitching environment, it all gets done to the advertisement RSpec. So there's going to be some requirements that once you decide which one of these methods you're using, you're going to have to go into your configuration so that when someone pulls a list resources from the GENI Aggregate Manager API and you get back your advertisement RSpec, it has to have a little bit of information. And what the information is, it just simply communicates what are the connections you have from that GENI rack, that GENI resource, to the outside world. So it all gets communicated in the advertisement RSpec. And then based on that, the stitching infrastructure picks that up and can figure out how to do multi-aggregate slice stitching. And just a little bit more on the advertisement RSpec, what we have done is we've developed a stitching extension for the advertisement RSpec. So it's, people are familiar with the advertisement RSpec format. There's a main body, and then attached to that we put a stitching extension. And you know, it has a minimal set of information. The only thing that's in the stitching extension is a description of the nodes that actually have some connections to the outside world. So we're not repeating everything that's in the advertisement RSpec in the stitching extension. We're just taking and taking the parts that have connection to the outside world. We're adding a little extra information, very specific to stitching, and that goes in the stitching extension. So we have a set of rules that says once you have your regular advertisement RSpec, here's how you construct your stitching extension. Of course, you have to know where you're connected to and how you're connected. I'll show you an example here in a second. In terms of the implementation status of that feature, ProtoGENI has implemented it, and of course it shows up in the InstaGENI implementation as well. We've implemented the Max Aggregate Manager, and we've started some work with ExoGENI, and so we have more work to do there. And then we expect to see not really foam aggregate managers implemented, but aggregate managers which are based on foam, thinking mainly of Internet 2's AL2S someday. So that, you know, there also needs to be some discussions about how the stitching extension gets integrated into that environment. So if you look at, you know, an example of what information goes in an advertisement RSpec, here's an example. So BBN InstaGENI rack is connected to Knox, which is connected into ION. Knox has just static VLANs provisioned across it. So if you do a list resources and pull the advertisement RSpec for the BBN InstaGENI rack, what you'll see in there is you'll see all the regular stuff that describes everything in the InstaGENI rack, but you'll see that there is basically an interface in the InstaGENI rack which is pointing towards Knox. And that'll be described, and you can read it there, and what you'll see there is that there's a link defined that basically says I have one local interface that's on the BBN InstaGENI rack, and the other end is on ION. You can tell that by looking at the domain name there of ion.edu. And then in the stitching extension right below that, you can see that that information gets repeated, and I'm showing a very short version of this. There's really more information that we have in both places, but basically the only thing in the stitching extension is that information that has an external connection. And if you notice, we have a VLAN range availability field which says 3747 to 3749. That's what's capturing what Knox has done. That's capturing the fact that Knox is only provisioned 2 static VLANs across there. So we don't mention the fact that Knox is in here because it's visible to the control plane, but we do capture the effects of their configuration, which is that they basically have a range of static VLANs. So now this goes out in the advertisement RSpecs, and now when we start to go do real-time stitching events, we now have the information we need to make decisions about what VLANs we can use and what VLANs we can. We have a whole system here which how Omni gets that information to actually get that into the integrated API slice create sliver request. So that's just an example. If somebody had a different range or a dynamic networking, very similar, there would just be some slight differences in how it actually is represented. So if you're a GENI rack or an aggregate manager, this isn't really necessarily what someone has to do is just deploying one, but as an aggregate manager developer, you have a couple of responsibilities with stitching, and they're pretty straightforward. Basically, they're internally, you have to be able to pull up your slice resources and map your stitching VLAN to it. You need to get that stitching VLAN expressed out to the edge of your GENI resource so that it's pointing outwards to whatever your externally connected resource is. And if you're running, just GENI AM API version 2, which everyone is right now, there's nothing extra required for stitching. Then from there, we just pick it up and we use the standard create sliver mechanisms in order to do stitching. When we go to GENI AM API version 3, the people who are developing GENI aggregate managers, GENI resources, are going to be, there's going to be a couple of extra things that we'd like to see happen. Basically, the paradigm shifts from create sliver to allocate and reserve when we go from version 2 to version 3. So we basically want to leverage that feature set, which is in there for other reasons, to facilitate stitching. It's basically it's going to allow us to be a little bit more sophisticated in how we find resources in real time across multiple aggregates. So there will be some changes, but right now we're just on version 2. So it's just a standard operation set to do stitching now with the current aggregates out there. From the stitching infrastructure perspective, because now, what we've done is we've had the aggregates provide us some information in the advertisement RSpec, and now the stitching infrastructure has to take over, and when a user produces a request RSpec that might have 3 GENI aggregates in there, we have to figure out how to stitch them together. So the stitching infrastructure job is to basically find a stitching VLAN that's going to work across all those multiple aggregates. And it's going to interact with all the individual aggregates managers in a standard way, and actually the stitching infrastructure does not directly interact. It's going to be the same set of client tools that are always used. Right now we're testing with Omni. Eventually, maybe GENI Portal or a FLAC or something like that. But we want to be able to make sure we can do this in that ecosystem I showed, where we have campus and regional wide area networks, all possibly running different types of VLAN provisioning mechanisms, including static, and with these GENI resources showing up in very ad hoc ways. So when I talk about the GENI, the stitching infrastructure, I'm really talking about a couple of things, and I'll talk in more detail about the actual architecture. Is basically the extensions to the RSpecs, the topology services. We have a computation service, and then there's a stitching library that goes in GENI clients like Omni. And we want to be very transparent to the user. So, for instance, we want to be, if the user is just interested in a slice that goes across 2 aggregates, say like, the example, the testing that we've recently been on, maybe an Instant GENI Rack, Proto-GENI Utah. We don't want the user to have to generate an RSpec that has any more in it than that. The fact that we have to find other GENI aggregates or other networks to go through to get there, we want the user just to be able to provide exactly what they want. The stitching infrastructure will take care of expanding that as required to figure out what other aggregates need to be contacted. So if we look at the stitching architecture, this is a graphical representation of it. So basically, on the left there, we just show that all the advertisement RSpecs are going to be pulled from the GENI aggregate managers, just with the standard mechanisms, the list resources call. And through the stitching extension, we'll get some extra information, and we basically have information in there that tells us whether or not a specific aggregate or a specific node inside an aggregate can do VLAN translation. There's things that different aggregates can do, like some are VLAN producers, some are VLAN consumers. So we capture all that information in terms of capability sets when we pull that information. And we'll go into the topology service, which the job of the topology service is really just to accumulate the list resources, okay? And it's not, it's really just so it's kind of have a central place in the global topology, so we can get a view of the global interconnected space. And then from there, we have a computation engine. So Omni tool has a stitching library that hopefully will soon be released, that when a simple request like you see on the left comes in, and Omni says, okay, I need to find out exactly what aggregates I need to contact to make that happen, it'll send it over to the computation engine, which is fed by the topology service. And what it'll get back is basically an expanded RSpec. In this case, you see it got expanded to put ION in the middle, along with a set of workflow rules. So based on that, Omni now knows how to go down and contact all the aggregates in the chain and ask for things to happen and actually get the slices instantiated on all the aggregates and the stitching VLAN provision. So the rest of these things I'm going to go through them real quick because I'm out of time is real details on that architecture and just the implementation status. But I want to jump ahead and just talk about where we are today in terms of ability to do this. There is some dynamic networking infrastructure out there that we can leverage, and it's Internet 2's ION service. A lot of it is based on the dynamic circuit network infrastructure. So the DYNE system funded by NSF has basically resulted in this type of capability out there at about 40 different places. So there's going to be a lot of places where GENI racks show up and we'll be able to leverage that infrastructure. So we do have that incorporated into the architecture, and we've been using that. And we want, when other types of dynamic network technologies come along, like OpenFlow or NSI, we want to make sure we can incorporate those, and I think that'll be pretty straightforward for us. And specifically, Internet 2 is now running a GENI aggregate engine on top of ION. So when people are using their regular, GENI tools like Omni, they can talk to Internet 2's ION service just like they talk to any other aggregate and make the network stitching paths happen. And when AL2S comes along, right now, ION is just point-to-point Ethernet service. When the AL2S comes along, that's going to open up more types of topologies, like we can do multi-point with true layer 2 broadcasting. So there's some work to do there about how to actually expand the service set that we have on ION now, point-to-point, to what is possible once we have access to the AL2S network in the GENI context. We've got to do more complex topology. So that's on the roadmap to figure out exactly how to do that. But today, you can hit up ION, the GENI API. So where we are is we're testing this right now. We've done a lot of testing between BBN and Proto-GENI, Kentucky, and Prime, LSU. And we're working with Aaron Helsinger and crew to get a new version of Omni out there that's stitching, and hopefully that'll be very soon. And we're hoping, between now and GEC17 to make that more available for people to test and use. And that's it. Do I have more time?
Can I ask a question,
Yeah,
Tom?
there should be at
So,
least one.
well, no, this is great. I'm just thinking about, based on the talk you had at the end of the last one, what if the unit of currency wasn't a VLAN tag that goes between, but it was an MPLS ID, or it probably isn't true in the GENI context, but some net10 IP address was in fact the thing that mated the two. Do you think this is extendable that way, or have you thought about doing something? I'm just thinking about when you've got OpenFlow everywhere, say, and you don't actually have to have a VLAN tag. It's a thing
Yeah,
that
no, absolutely. So
connecting there.
we look at the details of the stitching extension. It's all geared towards allowing people to specify what is that stitching technology.
Mhm.
So it's very easily, you have to actually define what you want, but the infrastructure is designed that if someone comes up with a new technology to stitch, whether it's IP tunnels or UDP tunnels or MAC addresses because OpenFlow was provisioning it, it's just going to be a matter of going into the stitching extension and modifying how you describe what's on that inter-aggregate link. And then, of course, the hard part will be all the aggregates have to understand that and have to actually process it. So getting into the stitching extension and the stitching representations won't be that difficult. I think making so that aggregates can actually act on it will be the harder part of it. But yeah, absolutely, the stitching extension is designed to be extendable. We're just focused on VLANs right now because that's what everybody does, and you can only do so much more time.
Thanks.
I have approximately an infinite number of questions about this, but I'll restrict myself to just one. If you have a regional network, such as the one I have, that is OpenFlow switches, flow visored and phoned, this is not applicable. Because there's no, I can build VLAN-like objects on top of them with something like OESS, but I'm not running OESS, I'm running flow visor and phone.
So I think, I didn't talk about this, but there is an extension that basically, if you want to basically provision a VLAN over which you want your user to run a controller, right? Because it's an OpenFlow capable device, you can do that. So I think the question is how do you want to use your OpenFlow provisioning technology? Do you want to use it just on behalf of the user to provision a VLAN, or do you want to use it so the user can run a controller so they can make things happen on the VLAN that's been provisioned? Right? Both of those scenarios can be done. You see the distinction. So the answer to your question is today, if you were to test against one of the implementations that's deployed out there today, it would just be to basically provision a VLAN between slices. We have an extension that we're working on with BVN that basically will allow you to say, I want a VLAN provision over which I will let my user run a controller to do OpenFlow stuff. And I think that's the scenario you're talking about. Is that?
Well, no, I'm concentrating more on the first one. The only way to control those switches is via OpenFlow. So how are you going to provision a VLAN across them?
You can provision VLAN in OpenFlow.
I think there's certain different ways that you can do this, but for example, if you wanted to, I guess the stitching case is more like the experimenter is not necessarily running their controller,
Right.
and maybe you would be running the controller on their behalf. So you could imagine, say, Ethernet provisions, pre-provisioned slices via phone, points at a controller that you operate, and then the experimenter would go to the aggregate racks, the reserve resources that just tie into that, but you're running the OESS controller or whatever that provisions the VLAN tag through the OpenFlow network to get to the next point, the next network. As maybe that's one answer to this problem. Maybe not the best.
Well, can I throw another one?
I'm thinking that's not the best answer.
Well, but another one could be that the way you're talking to the rest of these aggregates is via VLANs.
Right.
So you're saying, look, we're going to agree that this is a VLAN that's going to be presented by the experimenter at this interface, and then it's going to work, stitch all the way across. And so it's their responsibility to put the VLAN there, I guess, so it all works.
Are you thinking the case now like phone today where it doesn't provision the VLANs, where you kind of assume the VLAN's there and you're going to do OpenFlow stuff on top of it?
No, I'm just thinking that in general there seem to be two flavors of networks. There are the OpenFlow enabled networks that are just running straight up OpenFlow,
Yeah.
and then there are the networks however the underpinnings are implemented that do things that look like VLANs, right? Whether they're real VLANs or not is not important, but they appear to be, clouds with VLANs on both ends. This emphasizes the clouds with VLANs on both ends model, which is fine. I'm not criticizing that. I'm just saying, how can you then extend that through the pure OpenFlow network?
So let me just, do you think there's a problem using OpenFlow to provision a flow space, which is VLAN based?
No, not at all.
Okay.
But let's say I'm a researcher, right? And all I want is a VLAN.
Right.
I don't want to do OpenFlow. I don't like OpenFlow.
Right.
I'm on the someday to be installed NicerNet InstaGenie rack in Syracuse.
Yeah.
Its only path out through the world is that pair of OpenFlow switches. They touch ion, so there's a way to do this, but it doesn't. I don't see a way.
Yeah. This is a case we haven't tested much. To me, I think there is a way, but I think maybe we need to have a more detailed conversation about this.
Okay.
I would love to actually set something up and actually test it.
Well, now's a good time because there isn't actually a rack sitting there, so we can break things as much as we want to. But
yeah, but to me, I look at OpenFlow that if you have an OpenFlow network, you might just use it in service of a user request to provision a VLAN, which came into an AM API interface. The user probably doesn't even know you're using OpenFlow in the background to get the VLAN. Or you might have a user who wants you to provision a VLAN so they can run their controller to talk to your flow advisor to do stuff on that VLAN you just provisioned. So those are the two scenarios that we've been thinking about and trying to cover.
Well, I think maybe the slight twist.
I'm going to have to stop.
never mind.
Sorry. Otherwise, Sarah won't be able to finish her part. I hate to cut off discussion when we finally have discussion. But.
I think that's more a hybrid mode he's thinking. So if you have a switch and it's VLAN 1750 is the one that is OpenFlow controlled, then this would help get it on so that you could do things. But
so right now, the way it works is Tim, for example, creates a sliver that is implemented as FlowVisor flow spaces that match on VLAN 1750. So in that respect, it works like that, and it ties in with VLAN 1750 events, but it doesn't. It's not the same thing.
yes, I agree. It's not the general OpenFlow solution, which is sort of why I was asking more about the matching.
It's the professional flow.
He's looking to recruit the next couple of regionals to test with, so.
Okay.
You have to work it out.
Can anyone hear me? Sorry. Okay, so I'm going to talk about make some proposals about policies regarding the new GENI Clearinghouse and portal. Basically, we are interested in your feedback on how to integrate or how to do policies with the new portal. So just real quickly, we'll talk about it a little bit. So the portal is really the portal is really a front end to the clearinghouse. The clearinghouse is how we manage experimenters, projects, and slices, and also a little bit of authorization to have permission to take certain actions. The portal is a web-based interface to that, and if you, there's 3 tutorials at this GEC that had used the portal. There was a portal tutorial yesterday morning. We had like 80 people there, so maybe one of them was you. And that went quite well. And then it was used at the advanced networking tutorial earlier this afternoon. It's going to be used tomorrow morning, the OpenFlow tutorial. This is the first GEC where we've started to have a meaningful number of users. So that's kind of exciting. And it's currently operated by the GPO, but we'll talk a little bit later that that's not really the sort of long-term plan. Okay. So we have this new clearinghouse and portal, but it's new, and it's sort of the same as things we've had before, a little different, and so let's talk about that. Let's talk about some of the risks associated with that, because what we want from you is we want to ask if you think racks should trust the this new clearinghouse. So we sort of want this to be an informed consent kind of discussion. So I want to talk about some of the risks and see if they're appropriate. So, so the GENI, the new Clearinghouse and portal, has the same function as like the GPO run ProtoGenie emula or ProtoGenie instance that we run. And so we're using sort of the same policies about who can become a project lead. And when somebody is a project lead, they're trusted to make their own decisions about who gets added to their project. So the policies between these two are the same. So we think this is not an area of great risk. And just so everybody's on the same page about what is a project and what is a project lead, projects are sort of how you organize experiments, right? So we have, projects can have people in them and they can have experiments in them. The people, usually you have people who are members, but there's always a project lead who is the person who's responsible if something goes wrong or we need to contact them. There's somebody that we really need to be able to contact, to email to or to call in case of a problem. And the experiments are represented by slices. So who can be a project lead? So currently in the GENI portal and also in our ProtoGenie, the GPO ProtoGenie slice authority, basically it's anyone who's academic faculty or senior technical staff at a company or nonprofit or some sort of non-academic environment. So you need to be somebody sort of who's going to be around a while, who has some seniority, who can understand and take responsibility. All right, so second area where there might be some risks has to do with security. And we believe that the security risks are similar between the Clearinghouse and the existing ProtoGenie, GPO ProtoGenie instance, which I refer to sometimes in the slides as PGenie, GPO Lab.BBN.com. So in both cases, the host could theoretically get compromised, certificates and keys could be stolen and used to reserve resources at an aggregate. And in both cases, if this was detected, the root certificate could be removed from the trust bundle so that the stolen certificates and keys were no longer valid. And so this risk is comparable in these two cases. All right, so the last risk is basically that the portal clearinghouse is new. And this is sort of one of those things we don't know, right? There could be bugs. But as with all things, right? But because it's new, there's probably more bugs than there will be, in 6 months or a year. So basically, we have there's several of us who are actively working on the portal, and we consider it a very high priority thing to fix critical bugs as soon as they show up. And while it's theoretically possible that we could somehow allow erroneous requests to a rack aggregate, that particular path has been tested quite thoroughly, and we haven't had any issues with that. So that's sort of the things that are risky about it. And so we'd like to make a recommendation, and we wanted sort of your approval for it. So the recommendation is that there are 4 GENI trust anchors: Utah ProtoGenie, Planet Lab, the GPO ProtoGenie, aka the BBN, or the PGenie GPO Lab BBN.com, and then the new GENI Clearinghouse. Of course, campus owners and operators have the ultimate authority to modify their trust bundle as necessary, but if the people in this room agree, we'd like to make the suggestion, we'd like to make this the standard recommendation for new GENI racks as they come online, that these are the 4 trust anchors that they should support. Does anybody have anything to say about that? Think this is a great idea, a terrible idea? Any concerns, questions?
What's the current recommendation? Is it the first 3?
I believe so. Yes.
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 Is Utah ProtoGenie the same as Emulab?
Yes.
Okay. And is Planet Lab still kind of a going concern, or is it?
Yeah.
Okay.
You don't hear us talk about it a lot on GENI because it doesn't have any layer 2 connections.
Uh-huh.
So in all these sessions, it's there, but we don't hook things up to it.
Right, but in the
There's lots of
particular
live ones.
in the particular sense that's relevant to this, they do
they have a lot of users and they share those users as a slice authority. So if people, if people trust their certificate in the way that we're talking about in this presentation, then those users get to use their resources. So that's kind of what we're talking about here. Isn't so much Planet Lab as resources, but slice authorities, so people who have users.
Okay. But that's a one-way street, right? You get credential for Planet Lab works on GENI, but not the other way?
So right now Planet Lab also trusts some of these others.
Oh, okay.
So.
Yeah, and in particular, I think they're the only ones with the current AMAPI v3 implementation. So they're like actually leading the pack in that regard.
Okay.
Okay, so anybody want to second this? Anyone want to throw tomatoes? Anyone? Final? Bueller?
Is the new box under Tim's desk, or is it in the same place that everywhere else?
Good question.
That's an excellent question. And it's in the GPO lab, and it is, I don't know how to describe it. Chaos, do you want to answer?
Sure, I can try. So it's currently being maintained by GPO's software development group. Obviously our operational group, runs the hardware and the operating system. We are, obviously those of us in operations are working pretty closely with them. To some extent, we are, we're running to catch up with some of the stuff that we've already had in place on the other slice authority we run, but that's definitely, we are definitely actively working on, in all the ways that count, making those things behave in similar ways. So, I think we're not quite there yet. I think we are very actively working on it, and
I think it's fair to say that the portal clearinghouse is still, beta, alpha, maybe. Yeah, it's still in development. Yeah.
I'd like some more discussion before I second anything.
Excellent, great.
Matt, who is Internet 2 trusting?
Right now, the phone is probably trusting the first three.
Now, what about and I know that there's some technical mismatch here, but what about InCommon?
Excellent. I'm going to talk about InCommon in a second. So what do you, so,
You're asking who does InCommon trust, or who trusts InCommon?
InCommon is a very formal way of specifying who trusts what and how to get credentials and how I know that you're the real.
There's a relationship between InCommon and the portal, and the next set of slides is about that. Do you want?
No. You're right, because the InCommon trust structure has to have something that is therefore trusted by relationships, right? Yeah. So I guess. Let me phrase it this way. What would make sense for an InCommon trust structure to trust that would be a recommended trust anchor for GENI?
I don't know that I understand the question.
All right.
I'd probably turn it the other way around. It's like, what should GENI be trusting in order
So,
to
right.
have experiments?
Yes.
Do you want me to talk? Do you want me to go through the next couple of slides real quick?
So, just as I guess as a backbone person, I think this is a reasonable thing, especially since, for us, we're running the GENI switches on your behalf, so whatever you say is fine with us. But I think that this is a way to get to the clearinghouse. You're treating it, as a first-class citizen, and if I trust all the rest of the stuff, I think this is a reasonable thing to do.
I second your motion.
Is anyone violently disagree or mildly disagree? Yeah.
Can I ask one other question?
Sure.
What would the side effect be if in the future some portion of the GENI infrastructure only trusted a subset of those?
Right. So what that means is that you can't do things like reserve resources at those AMs, right? And we've actually had that situation in the past where not all of these were trusted by all the mesoscales. So if you wanted to do, I think, phone things in the mesoscale, I think you needed to have a GENI GPO lab credential. I believe you could from Utah, if my memory serves.
So part of this will depend on, the goodness of all this will depend on, you know, not just the people who administer the racks, but the people who administer, for example, once AL2S provides a foam AM.
So-
Its foam will have to be configured to trust the same set.
Right, absolutely.
Yes.
Well,
Or we can make a decision that we're only going to trust the GPO and not those other. Whatever.
I don't think anyone's suggesting that.
Yeah.
Not an all or nothing.
Right, exactly. And like it says, you know, you can make your own choice. If people decided later that that wasn't a good idea, you know, we can change our minds. I think that's I don't think a huge issue there. But yeah,
So Sarah, I guess I'm almost making the assumption that the GENI Clearinghouse as a new entity
Yeah.
is subject to the same criteria that the other trust anchors have already signed up and adhered to as well.
what kind of thing in particular?
Well, no, just, I mean, that in order to be a trust anchor, there's a certain set of qualifications, if you will. And that,
Like being a certificate authority.
Yeah.
you know, and so there's some equal weighting, if you will, to the responsibility that the clearinghouse is accepting, similar to what the others, the trust anchors have accepted.
Yes, I think so.
I can talk about that if
Good,
you want.
okay, that's fine.
Yeah, so I think to some extent, like, you know, in large measure, a lot of those responsibilities, you know, revolve around the idea of keeping track of who these people are, who you're allowing to use, you know, GENI resources, and that's kind of what I was saying to Matt earlier on the subject of, you know, that basically since we're sort of the same set of people, so our ideas about, you know, what constitutes reasonable tracking down of users are going to be pretty similar. Between, you know, and as Sarah was saying, you know, we let the same sorts of people be project leads and bring new people into GENI. We're putting into place the same procedures for keeping track of users and making sure that they're still active and that kind of
The
thing.
answer is yes. Thank
Yeah.
you.
Yeah, exactly.
Yep.
Yeah. In
Long-winded,
particular,
but
KF comes and asks the same questions in the same way for both. So. All right,
One last question.
yes.
You note that PG&E is legacy. Is it on a,
Sorry.
is it on an
All
exit?
three of them, not just that one. All
Oh.
three.
Okay.
They're existing things, and our plan is not that pg.gpo.vbn.com and the portal and clearinghouse both exist for all time.
Okay.
Our hope is that there will be a transition, and that pg.gplab.vbn.com will go away.
Good.
We need to find a way to transition those users, and that the portal and clearinghouse replace that, because our reason for doing the portal and clearinghouse is to make things basically easier and better for experimenters. And so we'd like to move them that way as we do it. Sorry.
Yes.
So, right, so it's not, the intention is not, you know, in 2 years or something, our hope is that there will not be 4 here. Or if there's 4, it'll be a different 4.
Right, but obviously for the, you know, for the phrase planning a transition, read time well past.
Yeah.
Right.
Sure, right.
But we can't start that transition unless some people trust us.
My goal as someone who is regularly confused by all of this is to have the ability to focus on just one that
Exactly.
can do everything
Well-
and ignore all the other ones. So,
Well, and we're trying to make some of that stuff easier. We may have in this immediate moment increase the number of places that you can get accounts. But our hope is that ultimately we can reduce the confusion and make it simpler and easier for experimenters. All right. Do we like this?
yes.
Do we
Yes.
believe you know what you're doing and making sure you're not compromised?
I mean,
Are you the real Sarah?
I have a badge that says I'm Sarah.
There you go.
I think we,
Yeah.
yes.
So we'll follow up and send out emails to GENI lists telling people that we had this discussion and that folks in the room thought it was okay provisionally to go ahead, but, you know, not everybody's here, so we'll give
Hum that was
people
all
on.
in agreement.
Right.
Sense of the room, the sense of the room approved.
Right, exactly, and see if anyone protests loudly or whatever.
Nobody brought,
Do you have
nobody,
an expiration date on the teacher certificate?
I did not install that certificate, so answer that question.
okay. All right, good. So the next thing has to do with InCommon. So one of the things that the portal does that some of these other places to get accounts and don't do that's new for the portal is that we're leveraging InCommon for single sign-on. So for those of you who don't know, InCommon is a way for, basically, if you're at a university, you probably have a username and password and an account that is issued to you by the university, and you can use that to log into things like the library or anything else. InCommon is a way for all of these schools to sort of set up trust so that a third-party website can use that same account. And so this is exactly like using your Facebook account to log into some website that's not Facebook, or using your Google account to log in to some other website. And so what's happening here is students at a university, say the University of Utah, can come to the portal and they can log in with their Utah username and password. They're just in at the portal. If you happen to not be a member of an institution that's part of InCommon, the GPO is running its own identity provider, and we are more than happy to make you an account. And so you can get in through one of those two methods. There's for people who are members of one of these institutions, this means there's no new passwords, there's familiar login screens. We're not responsible for keeping track of you and resetting your password if it gets wrong. But it also means that somebody out there is guaranteeing that you're a real person who's a real student, faculty, or staff at this institution. And so there's a real sense, I think there's a sense of sort of knowing that people are like a real person at a real place. The portal needs a couple of attributes that aren't usually shared by InCommon, and I'm going to talk about that a little bit more in a second. Okay. So like I said already, the portal trusts two things, that any InCommon institutions and the GPO identity provider. So anyone with an account at one of these places can log into the portal. Anybody. You can go do it right now. But when they log in, they have no privileges. Fine. Basically, becoming a member of a project is what allows you to do anything interesting. And as you heard me say before, we're very particular about who we give the ability to create projects to, and that project lead is taking on real responsibility to approve people who come into their project, and they're ultimately responsible for what happens with their project. And the Clearinghouse and the portal have tied together tied projects in more tightly. So like a slice URL coming from the Clearinghouse includes the project name in it. So there's a very real sense that they're tied together. Yes?
So educational institutions obtain some means of determining that people are real people. But then you're saying that GPO is running basically a catch-all ID. What are GPO's procedures for determining the existence of validity?
Great. So what happens right now is you send an email, and you have to have an institutional email address from a real institution. And we send you an email back asking for certain information, but you have to be able to reply from an email at a real institution. So you can't just give us our Gmail account. You have to give us your, utah.edu email address or whatever. And we're working on these procedures and improving them by the day. We're sort of, some tutorials in the last couple of weeks are our first real flush of doing this on a meaningful scale. I think it's in a real sense, we know a lot of the people who are getting accounts, or they're like, coming for GEC. We took the people who signed up for the tutorial for GEC and sent them, said, hey, please try this for us. Come join our thing.
The next question then is, so when an institution then decides to become a part of InCommon, what happens to the account that was created in the GPO IDP?
That's an excellent question. So if that happens, you can send us an email. Right now it's a manual process, but we can switch somebody's identity over, and we've actually already had to do that a couple of times. And so that's actually, yeah. Cool. Right. Good. So I said there were some caveats about information that we need from people. So The portal gives access to real resources, therefore we need to be able to contact experimenters if something goes wrong. So there's 5 pieces of information we'd like, but 2 of them we really, really need from InCommon institutions. One of them is this EPPN, which is sort of this unique identifier of a person and their email address so that we can contact them if there's a problem. And we also like to receive your affiliation and your first and last name. So this is easy to turn on, and InCommon has created this research and scholarship category, or RNS category. You can go turn that on in your configuration and share these attributes, and that's a pretty seamless process.
Can you skip this one?
Yeah, okay, sorry. Okay, so wait, real quick, we'd like you to try it out. If you try it out, send us an email at Portal Help and we'll help you make it happen. Okay, good. So, third thing we want to talk about is policy support. Okay, so currently, policy, the informally and the non-formal process is that RAC should accept anyone with a valid GENI credential on a first-come, first-served basis. Currently, there are no mechanisms to enforce any other policies. However, we think that maybe there should be, because we think that there's a couple of situations where we might need to enforce other policies. So the first one is, the first one's obvious case. Somebody has a RAC on a campus and they want to access resources in that RAC. That's sort of the typical case, and we think that's probably fine. The second thing, though, is that a RAC could be connected to other resources on campus. And those other resources might have an AM in front of them, in which case things are probably fine, but they might not. And so anybody with a GENI credential can come in and use things on a first-come, first-served basis, would just allow them into the resources behind the RAC. So the question is, are there other policies that campuses have that would control whether or not they would want to give people access to those other resources in the GENI RACs themselves? And basically we want to know, because if you tell us now, there's a chance that we can implement something to enforce those policies, but if we don't know what the policies are, the nature of the policies, it's hard for us to implement something. So we'd love to hear, just take a moment, we'd love to hear what policies you have to enforce the resources that you connect to your GENI RAC or your GENI RAC. Anyone? Yeah. Good.
So I'll speak from the point of view of deter stuff, where we actually do sort of on-demand space and time sharing. So we often have large experiments that want to use 100, 200, 200 or 300 nodes at a time. Test beds about 500 nodes. And so we actually have to deconflict people who need reservations. There's the mode where you're running for like a paper deadline.
Yeah.
You need 24 hours or 48 hours a week. And there's other people who run long-term things. Sometimes they say a month, a couple of months before collecting data. So those 2 categories seem to be the typical reservation things. There's also a sort of class usage model, which is sort of handled separately, where faculty members of course, their students need to run labs with a small number of nodes. There's a lot of students, and they have all of them sort of deadlines that come from the calendar, so we have a calendar for that. So those 3 categories seem to be ones you need to track. Right now, we do a lot of human level intervention, because only the humans involved in shepherding those experiments on and off can kind of make judgment calls and push down priority and confidence. I don't know a good way to scale this thing up for the GENI level order 100 RACs, but the policy should probably recognize that people who have paper deadlines are going to need resources.
Right.
Some preemption or at least light emails to see if we can make that happen should be facilitated.
Cool, that's great. Anybody else? I have a couple of things I can toss out there. Sort of things we thought of were sort of the number of resources or the percentage of resources. Maybe you would want to reserve some percentage of resources to your local campus so that they get priority, maybe not. Maybe VMs and bare metal machines are sort of have different values, and therefore maybe you can get more VMs than bare metal. There might be other equivalents for other types of resources. Maybe you could imagine limits on project slice or user sort of the basis, right? Maybe a project, if long-term projects that last months, maybe they get a different set of policies, or maybe a particular user is, a power user, that kind of thing. Anyway, so
Stop.
okay. So anybody else have any others?
Follow up an email or?
Yeah, so drop us a note. Yeah. Okay. And so finally, one last thing. So looking forward, there's the plan is not that the GPO run the portal and clearinghouse forever. It's going to transition to some other entity. That means two things. The policies we have now have to be okay after we hand it off. And we were wondering if there were any requirements on who would be acceptable to implement those policies. So that's a question of like, if it's a commercial entity that was, running and implementing the policies, would that be okay? Does it need to be some sort of other educational or nonprofit, anything like that? Does anyone have any concerns along those lines?
One that comes immediately to my mind is with regard to the IEP and the attributes that you want. I'm wondering, as soon as you said that first name and surname might be involved and there's going to be students here, there's a possibility of running afoul of FERPA if it goes to commercial entity.
Sorry, of what?
Federal Education Rights and Privacy Act.
So some institutions do not share those attributes, and that's okay.
Yes, and that's perfectly reasonable, but it's just a question of whether or not if we have a catch-all IEP that's running as GPO, does GPO try to even request those attributes from the students?
We do, and the student can volunteer it. The student can tell that they're needing to sandwich maker at the dining hall too, right? And they're willing to be asked for information.
They can ask that questions, can you publish?
Sorry, published? Published. Good. So we have a privacy policy for this.
Sorry, now I
You don't have policy?
Good question.
We're asking about a very specific case here, so yes.
Okay, that's my last slide. But I'm going to flash this one up. So, in the next 12 minutes before the bus leaves, if you feel the urge to wander by panther.gpl.wbn.com, you can try logging in. If it works, then you know it works for everybody at your institution, or should work at your institution. And if it doesn't work, you can drop us a line at Portal Help, or you can pester the appropriate identity person at your school. It can be awesome. But we will make sure the right person gets poked if you do that. So I'm going to leave this here.